Hello and welcome for the today's discussion. Myself Vishwanath Auti, and today we are mainly discussing two portions, and one is factor affecting duty of water crop, and and the and different methods adopted to improve the duty of water. So here one is factor affecting duty of water crops, and the different methods adopted to improve the duty of water. Right, and then we are discussing important questions. And here, first one is we'll discuss factors affecting duty of water crops. Important. And here is a list, and almost 12 points are there. First one is method and system of irrigation, mode of applying water to the crop, method of cultivation, time and frequency of tilling, types of crop, base period of the crop, climatic condition of the area, quality of water, method of assessment of irrigation method, canal conditions, character of soil and subsoil of the canal, character of soil and subsoil of the irrigation field. These are the maximum 12 points, and we'll see one by one these methods. And first one is method and system of irrigation. We studied the system of irrigation, right? And here which method we are adopting, based on that how it affects the duty of water. And here the perennial irrigation system, soil is continuously kept moisture, right? As we studied, perennial irrigation system is soil is continuously kept moisture, right? It is called as perennial irrigation system, and hence the water required for initial saturation is less. Initial is required less, and also due to the shallow depth of water table, deep percolation loss are less, right? So initial saturation is less, and also due to the shallow depth of water table, deep percolation loss is less. And in the inundation irrigation, there is a wasteful use of water. Hence, a perennial irrigation system has more duty than the inundation irrigation. So here we have to understand two factors. One is perennial irrigation system and inundation irrigation system. So as we know, perennial irrigation system is a soil continuously kept moisture, means there is a less requirement of water. So when is a less requirement of water, and from the remaining water we can cover more area. When we are covering the more area with the available water, then duty obviously will be more. So but if you take the example of inundation irrigation, continuation use of water, and there will be loss of water, right? So due to the loss of water in inundation irrigation, comparatively duty will be less, right? So then the flow irrigation has lower duty due to conveyance losses, right? Flow irrigation with the help of canals, and due to the losses, conveyance losses, duty will be less, right? Then while lift irrigation system has higher duty, you can see here it is, right? We are using lift irrigation, right, from the borewell, and due to the nearby the source of we are making irrigation nearby the source, then we can cover more area with the available water, right? So due to that, lift irrigation gives higher duty, right? And even tank irrigation gives higher duty. So here we are perennial irrigation system gives higher comparatively inundation irrigation, and lift irrigation gives higher duty, right, comparatively for even for perennial irrigation system, and even tank irrigation gives higher duty. Next method is mode of applying water. Mode of applying water. The flood irrigation system has lesser duty. Flood irrigation means, you can take this example of paddy agriculture, right? Inundation irrigation, water is flooded, right, in the agriculture land. Because of this, duty will be less. And then the furrow system, right? You can see here it is a furrow system. Even you can see in the image, these are the channels. You can see here, these are the channels are created, and these are called furrow system. And due to water conveying through this, there is a less use of water and more covering of the area. Due to more covering of the area, duty will be high comparatively with the flood irrigation, right? So next is method of cultivation. Method of cultivation. If the land is properly plugged and made quite loose before irrigating, the soil will have higher water retention capacity. So here it is, higher water retention capacity. When we will get the higher water retention capacity, when the land is properly plugged and made quite loose before irrigating, right? And it capacity in its saturation unsaturated zone. Thus, the numbering of water can be reduced. So, number of water can be reduced means there is a saving of water, increases the duty, right? So, whenever we are decreasing the use of water and covering more area, then definitely it gives the higher duty comparatively. The old and conventional methods of cultivation use lesser duty in comparison to the modern methods, right? So you can see here it is, you can call loosening of soil, and due to this loosening of soil it has holds a good amount of water in unsaturated zone. Next, fourth method, time and frequency of tilling. Time and frequency of tilling, right? So frequency of cultivation reduces the loss of moisture through weeds. Frequency of cultivation reduces the loss of moisture through the weeds. Soil structure affects the plant growth to very greater extent. A good structure, that is the good arrangement of soil particles in a relation to the one another, right? And is a good tilth of soil, right? So here good structure is called good tilth of soil, and when the soil is in good tilth, evaporation loss from the surface of the soil is less, right? So whenever we are making good tilling of the land, then it gives the good tilt, right? You can, right? Good tilt, here relation is good tilt. So when you have a good tilt, evaporation loss from the surface of the soil is less. When we have a evaporation loss less, then there is a saving of water, correct? Less, and soil become properly aerated, and hence yield of the crop is also better, right? So because of good tilt and because of frequent tilling, right, and due to that we can reduce the evaporation loss, and due to the saving of water from evaporation loss, duty will be more. Next is type of crop, right? Here type of crop, you can see in the image, right? Here it is a kind of crop. So here rice, sugar cane, rabi crops and other kharif crops, correct? So rice, as we know, rice require more water, right? Area in hectares, you can see here it is 0.75 duty in 1000 hectares per cumex, right? So and sugar cane, you can see here it is the area, and here, so it is means type of crop, duty varies from crop to crop. So different crop has a different duty requirement, right? So as I given sugar cane, rice, these are the commercial crops and require more water, right? So then base period of the crop, we studied what you mean by base period of crop. So base period of crop is first watering to last watering of, like, first watering before sowing of the seed and last watering before harvesting, and it all depends on the type of the crops, right? So that's what it varies with base period of the crop, right? The base period of the crop is more, the amount of water required will be high, hence duty will be low and vice versa, right? Okay, so next, seventh point, climatic condition of the area. So mainly it is related to water availability of the area or moisture content of the soil. So if moisture content is good condition, then require less water, more will be the duty, correct? So climatic conditions which affect the duty are, one is temperature, wind, next is humidity, rainfall, right? And due to the high temperature and wind, evaporation losses will be more. As I told, when temperature, surrounding temperature is high and wind. So due to this combined effect, evaporation loss will be more and duty will be less. Whenever we are getting losses, definitely there will be duty will be less. A humid atmosphere reduces the losses, right? Humid means it is a moistured climate, reduces the losses. Rainfall during the crop period will be reduce the irrigation water requirement. So irrigation means artificial supply of water, correct? But rainfall is a natural supply of water from the crop. The duty will be higher. In this context, there is a two terms. One is duty inclusive of rainfall. So here for the duty calculation, there is a including of rainfall, or it is a consideration of rainfall. That's what it is called as duty inclusive rainfall. And second one is duty exclusive, means we are not taking consideration of rainfall for the duty. So that's what it is called as duty exclusive, right? Okay. So we'll go for next factor. Next factor is quality of water. Quality of water. So how we require quality of water for the drinking purpose. Similarly, plants and the soil also required good quality of water for the good growth of the crop, right? So here, if the harmful salt content and alkaline content of the water is more, the water will have to be applied liberally so that salt are leached off, right? This will in turn reduce the duty, and more fertility matter in water will cause less consumption of water and increases the duty, right? So that's what it all depends on the quality of water. If it is a salt content and alkaline content, it will be used with liberally, and salt, and it reduces the duty, right? And more fertilizing matter in water will cause less consumption of water and increases the duty. Next, method of assessment of water. So here method of assessment of water means calculation. It is a assessment means it is a calculation of water, right? Volumetric method of assessment always leads to higher duty. So you can see here it is a small arrangement with a channel, or you can call it as a notch, right? So from this we'll get to know the velocity of flowing water and the area of this notch, and from this we can get discharging water per time, or we can calculate how much water we are releasing to the agricultural land, right? So when we are making volumetric method of assessment always leads to higher duty because accurate calculation of amount of water. This is because the farmers will use water economically, means he will calculate and he will use carefully. If, however, the method of assessment is based on the area under the cultivation, the farmer will have a tendency to use more water, right? So that's what volumetric method of assessment always gives higher duty. Next method is canal condition. In an earthen canal, the seepage and percolation loss will be high, right? If it is a earthen canal, condition is what? Earthen canal. You can see it is a canal is made up of earthen material, correct? So then it has some losses, right? Losses are in terms of seepage and percolation losses, correct, resulting in a lower duty, right? If, however, the canal is lined, if canal is lined means this this canal is lined with the concrete, then the losses will be less, duty will be high. Duty will be high. If the high canal is so aligned that the irrigating area are concentrated along it, the duty will be higher, and dispersion of the irrigated areas with respect to the canal tends to reduce the duty, correct? So if it is canal is nearby the irrigating area, then duty will be higher. And here main two factors: if it is an unlined canal, losses will be more, less will be the duty. If it is aligned with the concrete, right, so then it gives a higher duty. Next, character of soil and subsoil of the canal. So here it is, character of the soil and subsoil of the canal. It is related to canal, right? If the canal is unlined and if it flows through coarse grained permissible soil, the seepage and percolation losses will be higher. So it is related to same almost same to condition of the canal earthen, right? So here what they are telling, if the canal is unlined and flows through the coarse grained permeable soil, permeable soil, the seepage and percolation losses will be more. As we know, there is a more seepage because more will be the voids, right? And the losses will be higher. If the canal flows through the fine grained soil, and such a losses will be less, hence the duty will be higher. So it is a comparison. If the canal is flowing through coarse grained land, then losses will be more, less will be the duty. If it is a fine grained, right, clay material, then losses will be less. So when losses will be less, higher will be the duty. Last point, the character of soil and the subsoil of the irrigation field. So here it is irrigation field, not with a canal. Here it is a irrigation field, means agriculture land. If the soil and subsoil of the field is coarse grained, percolation loss will be higher. Same. If it is a coarse, then percolation loss or seepage loss will be more. However, if there is a hard pan at the depth 1 to 2 meter, 1 to 2 meter below the surface, right? If it is a hard, like you can see the hard material or hard rock, then losses will be less. The percolation losses reduces. The duty also affected by the topography of the land. If the field drier, in order to supply water to the higher place, more water will be used and duty will be reduced. Here it is what, if it is a not level, if agriculture land is not leveled, here it is topography also is matter. If the field is not level, the condition is if field is not level, the lower portion gets more water. Lower portion, as we know, if it is a land is like this, so due to the gravity flow, water will flow towards the lower, right, and higher portions will get less water. And if you want to supply water for the higher places, then more use of water. When you are using more use, then duty is reduces, correct? Okay, so then we'll go for next topic is different methods adopted to improve the duty of water. After studying the different factors which are controlling, next we are going for how to improve it. If it is a reducing duty, then how to improve the duty of water, correct? So we'll see one by one, the points are there, right, similar points, right? And one thing is, when we get to know what are the different factors affecting for reducing the duty, then we can easily improve the duty of water. So first point is, suitable method of applying water to the crops should be used. Means here it is suitable method of applying water, right? So when we are making suitable method of applying water to the crop, right, so that should be used, right? Then from this we can reduce the losses of water and we can improve the duty of water. Next, the land should be properly plugged and leveled before sowing the crop, right? It should be given a good tilth. Means here good tilth has to be given, a loosening of soil. Next, third point, the land should be cultivated frequently. The land should be cultivated frequently to save the moisture content of the soil, correct? Okay, so then we'll go for next points. Fourth point, the canal should be lined. The canal should be lined, means if it is a lined canal, then there is a seepage, less percolation losses and seepage losses, and higher will be the duty. Next, parallel canal should be constructed, right? If two canals are required, then a parallel canal should be constructed. Then the idle length of the canal should be reduced. Then the alignment of the canal, either in sandy soil or fissured rock, should be avoided. If you are making the alignment of the canal, then if it is a sandy soil, so then it is not suitable and not preferable place for alignment of the canal. Next point, the canal should be aligned that the areas to be cultivated are concentrated along it. If the area is the canal should be aligned that the areas to be cultivated are concentrated along it. So whenever we are constructing canal or alignment of the canal, then we have to make sure that irrigating either side of the canal, right? The area is required watering from the canal. Next is, the source of supply should be such that it gives the good quality of water. So means good quality of water is required, and we have to make sure that the source of water supply should be have a good quality of water. Next, the rotation of crops must be practiced. The rotation of a crop rotation must be practiced. Next, the volumetric method of assessment should be used. As I told, volumetric method, not with the agriculture land, right? So volumetric means, for example, if it is a 1 acre of land, then we have to supply with the volumetric means we already calculated how much water is required. That is a delta, right? How much depth of water is required, and based on that, if you use, then there is a careful use of water, or you can call economical use of water. Correct? Okay. Next is the farmers must be trained. The farmers must be trained uh, in the proper use of water. Correct. So when they trained like a drip irrigation, right? So then we can save the water, and when we are saving the water, we can improve the duty. Correct. Okay. Next, the land should be restricted to the farmers so that they get only as much as land they can capable to manage it. So it all depends on managing, right? So it is redistributed, and based on their capability, how much they have a like no capability, that much of land will be given, and from that they can use, they will make agriculture based on other capability, and they can make proper use of water, right, based on their capability, right. Next is research station should be established in various localities to study the soil, the weeds, and conservation of moisture, right. So here it is what proper research is required locally, right. The problem concerning to economic use of water should be studied at research stations. So here it is proper research is required, time to time guidance is issued to the farmers. That's what nearby research station should be set up. Next, the canal administration should be efficient, responsible, and honest, right. The operation of canal system should be such that the farmers both at the head of the canal as well as at the tail end get water. So here it is, if it is the initial portion of the canal, that is called as head of the canal, and at the end portion or last portion of the canal is called as a tail portion. It not mean that only head people will get a more water, even we have to take care of the people who are using water at the tail of the canal, right. And that will be achieved from canal administrative staff. They should be efficient, responsible, and honest. Okay, we'll see now important questions. In December 2019 and January 20, there is a question for 5 marks. What are the different methods adopted to improve the duty of water? So here it is, improve duty of water. Correct. So then December 2016 and 17, there is a question for 6 marks. What are the different methods adopted to improve the duty of water? Same question, right? And there is a difference in the marks. Next, in 2017 and 15, what are the various methods of improving duty of irrigation? Same question, correct? Almost same question, but there is a different method of asking the same questions. Next, in June July 2014, what are the factors affecting duty of water and how can duty improve? Both questions they ask for 7 marks. Next, these are the references, and for today's lecture I referred Dr. B.C. Punima textbook, that is Irrigation and Water Power Engineering, then even Dr. N. Balasubramanian, but mainly I use it for this presentation B.C. Punimia. Thank you.